Okay, good afternoon, everyone. Here today my topic is an improved 60 post detection method based on multiple magnet tracking. My name is Shuang from Harbin Institute of Technology at Shenzhen. So magnetic tracking method is a good choice to track the minimally invasive surgical devices inside human body for the minimally invasive excision or operation. Because it can achieve wireless tracking and has no line of sight problems. Currently, the study mainly based on these things, such as the sensing method. Usually, the magnetic sensor area is used to sense the magnetic field, and the magnetic field source are usually the permanent magnets or the electromagnetic cores. And the magnetic model usually used is the magnetic dipole model. As you can see here, this is the magnetic dipole model. Here, H presents the direction of the magnetic dipole, and the XYZ presents the position of the magnetic dipole. This model is very simple and easy to calculate. However, its disadvantage is that it can only provide the 5D information of the dipole, such as the 3D position and the 2D orientation information. So our proposed method is to achieve the 6D position and orientation information, that is the 3D position and 3D orientation. The proposed method is that we use two magnets with different, with opposite magnetic moment directions and embedded together. We use the multi-object tracking method to obtain position and orientation of each magnet, and then use the constraint equations to further optimize it, and finally we can have the 60 position of the orientation information based on the relationship between these two magnets. Also, we use the magnetic sensor area to sample the magnetic fields. First, we will talk about the multi-object tracking method. Here, we also use the magnetic dipole model to track each magnet. Here, we can assume that we have two magnets to track. First is its position is denoted as A1, B1, C1, and its orientation is denoted as M1, M1, P1. The second one is A2, B2, C2, and M2, N2, P2. Where ABC is the position and MNP is the direction of the magnetic moment. And then if we have a sensor at the position of XI, Y, CI, its magnetic field can be calculated using the superposition principle and the magnetic dipole model. And after that, we can use the optimization method to minimize the errors between the sampled value and the theoretical value. Here we use the LM algorithm. By using this method, we can obtain the position and orientation of each magnet. Here we have to see that since magnetic dipole model is used, we can only have the 5 degree of freedom results of each magnet. So here is after we have the position and orientation of each magnet, we can use the relationship between these two magnets to get the 6 degree of freedom of the target. Here we can see that we have two coordinate systems. The first one is denoted as XYZ, is the global tracking system. The second one, SUITZT, is the coordinate system of the tracking target. The relationship between these two coordinate systems can be seen in that table. we see that the position, the center point of the local coordinate system ABC is the center of A1, B1, C1, and A2, B2, C2, and the orientation of the local system of each axis of the local system are defined as ST, YT, ZT, as can be seen here. So after we have each position and orientation of each magnet, we can have the ABC and the ST, YT, ZT, and we can have the 60 position and orientation of the tracking target. Also, since there is a relationship between these two magnets, we also put these constraint equations in the optimization. So here are three constraints. First is the distance constraint, and that is since we put these two magnets together, the distance between these two, between the center of these two magnets, should be constant. That is the sum of the radius of these two magnets. And second is the orientation constraint, that is M1, N1, P1, and M2, N2, P2 should be parallel to each other with the opposite direction. The third constraint is the coordinate constraint, is that, as you can see here, the ST and ST should be perpendicular to YT. So here is the second constraint. That this is the third constraint. So with these three constraints and the target function, we can finally to solve the 60 results of the target. So here is the experimental platform. We have built a magnetic sensor area with 8 magnetic sensors, and a target that is we combine 2 magnets together, and the volume ratio between these 2 magnets is 1.5. And so here, this is the tracking interface. And this is a video. So here is the position error of the final target after we have 16-fold test. So here is the position error of each, with orientation error of each magnet, and the final orientation error of the target. And in below, the table lists the orientation and the final orientation error. Also, we have demo experiments to compare the different ratios between the volumes. And here is the result. You can see that with the different ratio, the errors are different. Okay, in this paper, we proposed an improved 6-dipole detection method, which is based on the constraint multiple magnets tracking method. Experimental results have verified the proposed method. The average position error is 2.3 millimeter, and the orientation error is 4.3. Comparison experiments have also been carried out to study the relationship between the volume ratio and the position error. In the future, we will further improve the method to reduce the orientation error. Thank you.